Hey everyone, welcome to Office Hours. Woo! Get some coffee. Welcome to Office Hours right now. So with Office Hours right here, let's take a look at the first question. The first question is about DataCamp. So for 475, 474, let's take a look. So for 475, 474, we've got the Introduction, Intermediate R, Machine Learning, everything right here. All of these courses. You'll see the same sort of thing in 475 also. Completion rate. Wow. Look at these completion rates because probably people already did these in 320. So really great completion rates, but nobody's done these down here. Make sure you've done the introduction, the intermediate R. It says, I have no teams. I don't know why. Well, 2 seconds, Mohammed. Let's get that fixed up right here. Mohammed, I'm going to make sure you're in those. Let me go ahead and find you. You might have just added. I have found you. Add to teams. And there you go. We've got that all fixed up. And let me go back in. So Mohammed, take a look right now. I'm going to go to the 475 team assignments. You'll be able to see me here in a second. 475 team assignments right here. We'll see what people are doing here-wise. And let's take a look. But you should have assignments now. You should be able to see your teams. And it looks like some people have been working on, oh, you see 475 has less completion on the introduction to R and intermediate. Some people have already done the dashboards, which is amazing. But you should have your teams now. I think you might have just added. In that case, I have added you in. Great job. And this is where we start practicing. The more practice you have, the better. So it really just comes down to like sitting down, playing piano, which I should do. I got a piano over there. So the more you sit down, the more you practice, the better you get. Keep doing that. Keep practicing. Keep working hard. You got this. Mohammed, any last questions right here? You can go through and just keep practicing. But DataCamp really has a great platform for this. Like, you should have your teams now. You should have your teams assigned. I went through and added everyone this weekend, but you might have updated afterwards. I think that's got it. We'll see here. Kylie, we'll do some Canvas content here next. I think I got access. Do you think you got it? Awesome. And you can always access any assignment you want by just searching an assignment, just going through DataCamp the normal way right here. And you can just search for an assignment. And yeah, you should be good to go. Just go up here to the search and go to like Tableau or something. And Introduction to Tableau. If you want to learn Tableau, which is not something we cover, you could go right here and start learning Tableau. I've never covered it, but you can see right here all the learning of Tableau. Everything right here. Good stuff. Well, that's got it. That's DataCamp. Practice up. Be practicing your R skills. They're the most important thing for this class. But there's a lot of other great skills to learn, and DataCamp is such a great platform for that. Let's go back to the main screen. It is time for some Canvas content. Let's go look at that Canvas content and do a few examples right here. Kylie, so I'm going to need your help right here as we do some Canvas content. Working ahead on those Canvas content quizzes. Where's Canvas content? Here we go. Let's take a look on the main screen. So Canvas content chapter 1 and chapter 2 is due next week. So we got lots of time. Excellent work. 6 days to go, but let's get it done right now. So I'm going to go in here and I'm going to go to preview. So I am previewing and seeing a version of it. Now, we have right here the 3 types of variables. And so we're doing some definitions to begin. And here's what you want to do for Canvas content. Have your notes out. Put your notes beside you. And when you need it, look at your notes. Now, what I'd also do is I'd write down the question to study for the test. I'd make a little like a sheet of test questions right here to be like, these are really likely test questions, and be like, the types of data, the type of data, sections, items into groups, people into groups, items or people into groups. So does that sound like quantitatives, like quantities, categorical, like categories, or identifiers, which would identify? C, Q, or I in the chat. I need help from the chat right here. And this is good practice if you're in 320, if you're in 474. What do people think? I'm gonna go over here, see how many people we have watching. Got 3 people watching. Awesome. Love it. So, or 5, maybe 5. We got 5 people watching. Who knows? Miriam Mubot's here in the chat giving out those points. If you're interacting in the chat, it is categorical because it puts things into groups. So remember, if you are here, I don't know why it's not doing live chat. There we go. We got live chat going. Great job, Kylie. I need to set it to default live chat. It is categorical. A blank is collected to make inferences about a population. So what do we take to make inferences about a population? So we have right here quite a few words. I'm going to explain what they all mean. One of them, how do I know if my R is up to date? Run R version. I think it's r.version. A sample, great job. A sample. So you go out and you, imagine this. You want to know if Gordon Ramsay made a really good cake. Would you take a parameter of that cake, a statistic of that cake, a variable of that cake, or a sample of that cake? The cake itself is a population, like the whole cake, everything, the whole cake. And then you take like a slice of it and you say, sample's pretty good. Sample's good. The cake is probably good. Now, if you only took the edge of the cake, that would not be representative. You want to take a good slice of the cake that is representative of the cake you have. So what is a parameter? Well, parameter and statistic go together. The answer is not statistic right now. But if I were to, let's say right here, oh, so this is 201. This is 201 right here. So we're doing 201 right now. If I were to talk to 100 UT students and ask them their GPA, would that be a statistic or would that be a parameter? If I were to talk to 100 UT students, would that, and get their GPA, would that GPA, the mean GPA, be a statistic or a parameter? 4.1.1. So if I were to talk to 100 UT students, would that be a statistic or a parameter? And the thing we should remember is SSPP. It'd be a statistic. Great job, Sarah, right there. Let's throw some more points out in the chat. Re-download it. Re-download it. Yep. I'll show that here, Andrew, next if you want. Re-download it. Ah! So a statistic comes from a sample. And then if we were to talk to all the UT students and ask them their GPA, that would be a parameter. So the statistic is estimating the parameter. Does that make sense right there? Does that make sense that the statistic, 100 UT students GPA, we say like from 100 UT students, we found out a GPA of 3.8, then that would estimate the truth for all students, which is the parameter. It's just a big word to say like the true thing we are interested in for the population. The true GPA of all UT students would be the parameter, but then the statistic is what we get from a sample. Parameters come from what's again? A parameter is something that is true for a what? So put that word in the chat for 20 points. A parameter is something that is true for a what, which is estimated by a sample statistic. A sample statistic estimates it estimates a parameter, which is what is true for the whole group, which is and this is why we say SSPP, that sample statistics estimate parameters. Sample statistics estimate parameters. What's the word? Sample statistics estimate population parameters. Great job. Awesome work. We'll do another version of this. This is just good practice. And a variable is just like hair color, eye color. It's kind of like the wrong answer. That's just so wrong. We shouldn't even be there. All data needs what? You know this. We covered this a lot. We mentioned this multiple times. I made it pretty clear this would be on here. You are Mohammed. Yep. All data needs what? All data needs this. You should know this. This is like, you see this on the test, you're like, boom, 3 points. It means like when I say to, you say, what does to mean, Brian? To what? It needs context. Great job, Sarah, right there. It needs context. All data needs context. Uh-oh. New stuff we haven't covered yet. Let's do the new stuff. All data needs context. We need to understand what it means. So I've got right here, let me make it appear, all graphics. Where's my all graphics? All graphics. Here we go. This right here, take a screenshot of the screen right here. This is what it means to, yes, discipline meaningful. Exactly. And so if you look right here, do you see Pareto on this screen anywhere? Do you see Pareto? And we should see it. Do you see Pareto up there? This is a big cheat sheet. I think you should have 2 attempts. You should have 2. So follow along and you should get an A. So follow along, you should get an A. Muhammad is 100% right. Muhammad, 20 points right there. Do you see Pareto on here? Pareto is where? In the top left, bottom right. So it looks like a Pareto is what kind of, got it color coded. Take a screenshot if you want. This is a really good cheat sheet right here of all the types of displays we will cover. My fiance, amazing handwriting right there, wrote it out. And so this is a great cheat sheet, great review for any other class. Yeah, I'll put the links in the chat. You bet. Andrew will do that next year. You got it. What Where is a Pareto? Top right, which that means, great job right there, Kylie. That means that a Pareto is only one variable categorical. Does that make sense what a Pareto is? A Pareto is one categorical variable. Like, we could display a Pareto chart of, let's say, what high school did people attend? And then the most common high school would get the biggest bar, and it might be something like Farragut, because we are in Knoxville. And then the next common high schools would be lower and lower and lower and lower. A Pareto is a special case bar chart where they are put in order. We could do that. We could also do that, Roderick. Yeah, let's do that after Andrew's question. You got it, Roderick. That'd be good help. So a Pareto chart is a special case bar chart that has been put in order. Let's go view one quick example of that. I'm going to open up Jump here in the background. I'm trying to get Jump 16 working on my computer. Jump 16. I've had issues with downloading it from UT. I think it's because I'm here in Texas and they don't want me to have it here in Texas. So let's go over here to diamonds and I'll let you see the screen here. So if we were to take something like the cut of a diamond, C, Q, or I is what type of variable? Variable types is very important. Cut of a diamond is what type of variable? Cut of a diamond is what type of variable? The cut of a diamond. Is it an identifier? It identifies a specific diamond. Good to see you here, Cliff. Is it quantitative, like it's an actual amount? Or is it a category, which puts things into groups? The cut of a diamond, C, Q, or I, is what kind of variable? It's categorical. Great job right there, Andrew. 20 points. Amazing work, everybody in the chat. So it's categorical, which means right here that when we do the distribution of it, we can see right here a bar chart. Now, this is not a Pareto plot or Pareto chart. A Pareto plot, and great job, Kylie, right there. A Pareto plot, which we can do right here in Jump by going to quality process, there's the Pareto, is going to be a bar chart that has been what? What do you notice is the difference between a bar chart and a Pareto chart? And you're getting way ahead into a 1 if you're learning these things right now. What is the difference between a bar chart and a Pareto chart? So what do you notice is the key difference here between a bar chart and a Pareto, making it a special case bar chart? I'm just adding some options right here to make it nice and pretty. What is the key difference between a bar chart and a Pareto chart? That's weird. Should highlight both, right? Well, I guess it doesn't. Ooh, I don't like how it does that. It's being weird. A Pareto chart is a bar chart that has been what? So here's the Pareto plot, Pareto chart is simply a bar chart that has been put in what? Think of Pareto plot, put them in what? So here's the good notes. I'll repeat the good notes again to write down. A Pareto plot is a special kind of bar chart that has been put in order. Pareto charts and bar charts both display univariate, which means one categorical variable. Univariate categorical variables. Now, what's another type of display I could do to display this categorical variable? Does anybody know another type of display I could use to display a categorical variable? What is another type of display to display univariate categorical variables? 20 points in the chat right now. What is another type of display to display univariate categorical variables? I'm going to do it right here real quick. What is another type of display to display univariate categorical variables? It's on the screen over here. You can look up top right there for answers. Not ring charts. Everyone hates ring charts. So what's another type of univariate categorical display? So this is just different ways to display it. Yep, pie chart. Great job right there, Kylie. 20 points in the chat. You are correct, pie chart. And we're actually doing like visualization number 2 right now. So if you look at this, this is all just, don't do that to me. This is all just the same sort of thing. Does it make sense that this is just pick your one? Do you want to display it this way, this way, this way? These are all displaying the same thing right here, just different ways of doing it. We could add in here the percentages, and we kind of just did some visualization number 2. I do have videos for these, but you could go through here, and we should have, where is it? Oh, we have to literally go back and go to show the percentages down here, no labels, and there we go right there. So another step right there you have to do. But we now have kind of done visualization number 2, but we've covered how do we display univariate categorical data. Some of the best ways to display it are with a frequency table, bar chart, Pareto chart, or pie chart. Really great review on the screen right now of displaying one univariate categorical variable, which puts things into groups. Really great review. And this is when the answer right here is Pareto. I mean, bar chart, because it's special case Pareto. All that good stuff. The following histogram is skewed to the left. I love it. Left, right to the high, left to the low. Who knows the end of my saying? I will throw 50 points to somebody who knows the end of my saying. Right to the high, left to the low, whatever way what. When you're done, yeah, we'll start doing some lab 1. You got it. Right to the high, left to the low. Who knows the saying to get 50 points for those 201ers in here who are going to learn this? Who knows the remainder of the saying? Right to the high, left to the low, whatever way the tail goes. When we say low, great job right there, Andrew, getting the 50 points for everybody watching right now. Right to the high, left to the low, whatever way the tail goes. So what we're talking about right here is the tail of the little monster man. So this is definitely left skew, whatever way the tail goes. When I say low, this is the low side of the numbers. Left is to the low. Right is to the high. Be very careful. Sometimes they change the way these are. But does that make sense? Especially 201, this is your first time hearing this. Left to the low, right to the high, whatever way the tail goes. Or right to the high, left to the low, whatever way the tail goes. That way it rhymes a little bit better. But if you draw your little monster man and his tail goes to the left, that is the low side. So this is left skew. Also, this is known as negative skew or positive skew right here. But left to the low is negative skew, right to the high. So how would a right skew look? Well, let's just take a little quick picture right here. And we could draw something that is right skew. A right skew distribution would look something like this right here. And if you notice right here, if this were to go from 0 to 100, our little monster man's tail is going to go to the right side. So now the monster man has a tail on the right side, and that is right skew. Now I'm going to mention something here. So the answer is it left skew? That is very true. We got our first 100. We're going to do another version of this really quick. Then we're going to hop in 10 out of 10. Let's go ahead and preview it again. For those in 474, 475, so we'll do this one right here. So helping out with the advanced classes real quick, you can actually, under the mass package, I think, does it have skew? Nope. E107. There it is. So if you have a distribution, so this is for the advanced classes really quick right here, which is how we could actually do it. Let's say we have here survey 10, favorite survey ever, and we have here height. If we were to look at height, good practice for the advanced classes. If we were to look at height, what way is height skewed? Left, right, or not skewed at all? This is a tricky one. This is not a good Stat Tool 1 question. I would say it's a little bit symmetric with low outliers and maybe a little bit right skew. He's got a weird tail over here. This is not a good Stat Tool 1 question. I would not put this on a Stat Tool 1 test. And it's not really that skewed. It's got a little bit of low outliers. It's got maybe a buildup here on the right side. So it's maybe got some sort of right buildup or pulled to the right a little bit. So this is where we can directly answer the question by taking the vector and dropping it into skewness, which does the calculation. I was wrong. I should have went with those low outliers. It is mostly symmetric, but does everyone see this negative right here? The negative indicates that it is what skew, left or right. The negative indicates that there's a small amount of what skew. The negative indicates that there's a small amount of what skew. The negative would indicate there's a small amount of what skew right here, left or right. So this is how to like answer it mathematically. Because sometimes a little bit of left skew, and left is negative, left to the low, because its negatives are to the left side. If you want a really easy example right here, we could do random exponential numbers, 1,000. And if we take a look at this distribution is obviously what skew. This is obviously what skew. This is an obvious what skew distribution. So this is good practice for 201. When you look at these, say, that's obviously this skew. This is a great 201 question. We just said, what is the skew of this distribution? Right skew. That means if we throw it into the skewness function right here, which technically these are different random numbers, we should get a what number for those in the advanced classes. You should say, well, this should give us a what number indicating right skew. And skewness goes from 0 to positive numbers to negative numbers, with 0 being symmetric. So when we run a function to find the skewness of something, we should then get a what number out of this. Just don't think too big about the number. Just be, well, it should be this, positive or negative. Since it's right skew, the skewness function should return a what number? Since it's right skew, the skewness function should return a what number? And 20 points. Great job following along right here. Since it's right skew, it should return a what number? Since it's right skew, the skewness function will return a what number? Positive or negative? Right to the high, left to the low, whatever way the tail goes. Positive. Great job, Chloe, right there. Chloe, that's no Chloe jumping in. 20 points, Chloe. Thank you so much, Chloe. You are correct. Positive number. You got it. You got it. If you're 201, you just figured out a 474 question. Great job right there. You can do this in jump, just to show really, really briefly. If you do have a distribution like carrots, here's carrots. This distribution, does this look to be left or right skew? Well, I can definitely tell. Left or right skew in the chat. R or L in the chat. Left or right skew. So we're practicing. We're getting this down. L or R in the chat. Left or right skew. For that right there. And this was found under analyzed distribution. Left or right skew. And this is quantitative data we're working with right here. Quantitative. This is definitely R, right skewed. If you go here to the customized summary statistics right here, you can do the same thing we just did inside of R, and you can go and get the skewness of it by going here to skewness and then clicking OK. And guess what? Positive number, right skew. Skewness is not that big of a thing. Like it's just something we cover right here. If you've understood everything I've done, these examples, you have skewness down. Let's do the last example. We'll go a little bit quicker right here. We're just doing Canvas content, getting a lot of practice. Average chocolate rating. I, C, or Q. Earn those points. 20 points out there. Kylie and everyone, great job. Average chocolate rating, I, C, or Q in the chat. Just practicing the average chocolate rating, I, C, or Q. So you'd have to say, how much do you rate this chocolate? How much was this chocolate rated? How much was it rated? Definitely quantitative. And it looks like the company name is probably the identifier here. The company location could repeat. You might say, well, it doesn't repeat, but it could eventually repeat. A sample is used to make an inference about a population. What about, well, this is the true statement. We take samples, like you go and you take a sample of something to, like, you take some chocolate, you're like, okay, that's good. That's good chocolate right there. So you're making inferences about all the chocolate. And you might say, well, how do I know all the chocolate is good? Well, you're taking a sample that's hopefully representative of the chocolate to make inferences about all the chocolate. So definitely true. Samples make inferences about population. What type of variable is player ID? C, Q, or I? Peppermint Patty, good to see you here. And Roderick. C, Q, or I? Player ID. Player ID. That one's a little bit obvious. Now watch out. We do try to trick you with this. Player ID. It's like a unique thing for each player. Player ID, the last part of it, and I can't promise you if you see ID, it's always going to be this. Great job, Peppermint Patty. It's going to be an identifier because it's going to be unique for each player. Player ID should hopefully cannot ever repeat. So if we go and look up player 31,599, it's going to be the same player for each one. Good stuff right there. The IQR. So the IQR is the interquarters of the data, the interquarters, and I have my hours posted for people. If you think of 4 quarters of the data, these are things we'll be covering in class. So here's 4 quarters. Just think of it like the world you know. If I were to tell you the interquarters, how much data is in the IQR? And the IQR stands for the interquartile range. So it's the interquarters, and it's the range. But how much data is in the interquarters? Like, here's the range of the data. And range is going to be the lowest number, like the minimum to the maximum. That's the range. A lot of people done range, min to max. But the IQR is the interquartile range. It's just a range of the interquarters. What percent of data is in the IQR? The IQR contains what percent? Like this down here on the bottom contains 100% of the data. 100% of data is encompassed by the range. The IQR contains what percent of data? 50 points on the line here. The IQR contains what percent of the data? The IQR contains what percent of the data? Good practice. These are the basics. This is like practicing your C scales for 474, 474, 475. Practicing. Josephine, good to see you here. Mohammed, you're right. The IQR contains 50% of the data, the middle 50% to be exact. But I did ask what percent, so you are very correct. So the IQR contains 50%. And I just want you to think mathematically. Answer in the chat. Where does it start and where does it end? The IQR starts at a certain spot and ends at a certain spot. This is a good review. We'll be doing this in 201. The IQR starts, and just don't think too crazy. Be like, oh, it starts after this many this. And then it ends after this many this. Just count it up. Pretend these are on a table and be like, oh, this goes after 1 this, and this goes after 3 this. So the IQR is the middle 50% of the data, the interquarters. See how they're on the inside, the interquarters? And it's the range of them, how far they are apart. So the IQR starts at where and goes to where. It's your time to practice. I can say all the answers. I can say everything very quickly, but you have to practice it. So if you're sitting down at home right now, be writing down. The IQR starts at Q1, starts at 25%, which is Q1, and goes all the way to Q3, which is 3/4. Just think about Q3, 3/4. And we've almost written the 5-number summary, because right here would be the median. And we actually just did the 5-number summary also. 5-number summary is min, Q1, median, Q3, and the max. If you were paying attention to this, that's a lot of practice right here. A lot of stuff on the screen. The range is the min to the max. Yo, what's up, Ben? Good to see you there, Ben. And the IQR is the range from Q1 to Q3, the middle 50% of the data, the interquarters. We will be covering this in class. So trying to think what else to say on this. Let's look at some data real quick. Can you figure out the IQR of this data? 50 points on the line right now. Figure out the IQR of this data. So really good practice. Great job, Roderick, and everybody. Another 20 points, Roderick. So figure out the IQR of this data. See if you can do it. Remember, the IQR is just the distance these numbers are away. It's just how far is this number from this number? It's just the range of the middle 50%. There's the 75th. There's the 25th. How far are those numbers apart? That's all you're doing. It's just like the range is how far are these big numbers apart. So here's 2.5 to 0.21. The range is about 2.29. That's just how far those numbers are away. That's a range. You bet. You bet, Muhammad. We're doing that next. You got it. So what do you notice right here with Q3 and Q1? What is the range of these numbers? This is the bread and butter. This is where we practice right here. What is the range of those numbers? This is the interquartile range. It's just the distance things are apart. So how do we get this? The formula is Q3 minus Q1. You're just doing like max minus min. It's not max minus min, but it's the same sort of concept of big number minus small number. If you take this number minus this number, that's how far they are apart. So what is the range, the interquartile range? Just the distance those numbers are apart. A really good practice for the test. We'll ask sometimes on data, what is the interquartile range? So who knows? Practice, practice, practice. 50 points on the line here. Who knows? What is the interquartile range? Lots of practice right here. Who knows what the interquartile range is for this data? So you want to take Q3 minus Q1. Can I display both this at the same time? I don't want to block the thing while I do this. I can show you the answer by doing this. So if you want to practice, you can find out. So does anyone know it? Oh, we're going to lose the 50 points. Does anyone know it? Do Q3 minus Q1. There's the 75th percentile. There's the 25th percentile. The distance they are apart is... We're losing the points. Oh, no. There you go. 0.65. And once again, just make sure to do Q3 minus Q1. So Q3 is 1.06 minus 0.41. And there we go. Does that make sense? That we're just taking the distance those numbers are apart. And there is the interquartile range. So it's just the distance between Q1 and Q3. Great job, Herman Patty. I'll throw the 50 points out. Excellent work right there. Last question. We're going to do some 474 after this. is going to be select the appropriate type of this data visualization. So what do we have right here? You got to be very careful. This is a what? Well, we have questions like Cedar Point, Dorney Park, Happy Valley, CQRI. Are these categorical data, quantitative, or identifier? I see 6, 2, 3, 5. Is this CQRI, categorical, quantitative, or identifier? So someone said number of roller coasters by amusement park. So we basically asked, like, where is this roller coaster at? Be very careful. This one's very tricky. So we asked, where is the roller coaster at? And someone said, oh, this is a Cedar Point roller coaster. That was their response. So is this C, Q, or I? So I say, well, where's the Spinning Dragon roller coaster? Made that up. And they say, oh, that's at Six Flags Great America. And I say, oh, cool. So that was their response. Is this categorical, quantitative, or identifier? Categorical, quantitative, or identifier? You ask somebody, where is the roller coaster located at? And they say, it's located at Six Flags New England. Is this categorical, quantitative, or identifier? It's categorical. So which means we've asked one categorical question, and there are our options. So Peppermint Patty, what do you think we are going to use right here? What do you think this is? Take a look. You've got your cheat sheet here on the screen. What do you think this graphic is? I'll go between it so you can see. Now that you know it's one categorical variable, look up there at the top because it's one categorical variable, not where I'm pointing, but up. So what do you think it is? What do you think this is? Be very careful. It is categorical. So since it's one categorical variable, what do you think this graphic is? You've got your options up there to pick from. So what do you think it is? Do you think it's a bar chart, histogram, pie chart, Pareto, stem and leaf? Which of those sounds right? Let's see if chat can get it. I can say the answers, but it's really good if you practice. And don't worry if you're wrong. There's nothing wrong with being wrong, especially before the test. Even on the test, it's just a test. Don't let it define you. So what do you think here? Categorical, quantitative, or identifier? I mean, which one of these graphics is it? It is categorical. It's one categorical variable. So what is it? What kind of graphic is this? What kind of graphic is this? I think there's a very common wrong answer, which I will see often on this. A lot of people will be tricked into a wrong answer here. So what is the right answer, though? Who knows? It is a bar chart. Josephine, great job. A lot of people are going to say histogram, but histograms are only for quantitative variables. So we just did a histogram earlier. It does look similar. Let me go back and show that histogram again here. Histograms and bar charts are often confused because they look very similar. But notice on the bottom right here, the histogram has a quantitative axis. Great job, Josephine, right there. Another 50 points. Great job. Notice the histogram has a quantitative axis down here, and the bar chart, because this is a histogram, this is a bar chart. The bar chart has a categorical axis right here. Although these are numbers, these are just counts of observations. So someone did not reply 6. They asked, where's the roller coaster located? And they said Cedar Point. And there were 6 roller coasters located at Cedar Point. So you get a similar sort of thing when you do the carrots. One thing I don't like about Jump is it puts, used to put, oh, did they change it? So it doesn't say histogram anymore? Nice. But this right here is a bar chart also. So these are both bar charts right here because they are categorical. So the good, the ideal, and although this is numeric right here, this is just a count of how many diamonds meet that classification. And you can see right here, it is categorical, and thus we get a bar chart. And that's got it. We should get another 100. And let's see, let's start up some 474 right here. Another 100, 10 out of 10. Would take that quiz again. Great job. Let's put a break right here and do some 474. Andrew, I'm going to drop this in the chat. Make sure you download the most recent version of R. We're going to do some 474 here. So this is for Andrew. Let me go to the getting started. Downloading R. You might need to delete your old version of R. So if you have a problem, let me know. You might need to delete your old version of R, Andrew. But that's the downloading R playlist right there, or the getting started in R playlist. And there we go. Let's get started. Who's here for 474 and wants to do a little bit of the activity? Get started on some activity right here. Let's go take a look. 474. Oh my gosh, they changed me over to the semester. I think it changed. Are you making the videos as you go? Some. Got all different videos. You are here, Muhammad. Awesome. Working with data in R. Working in data R. Let's do this. Let's head over to the main screen. Here we go. So the solutions are not yet available, so we can't see the solutions yet. But let's go over here to Lab 1 RMD. I'll probably do most, kind of a lot of things. Let's go over to Retailer. Let's open this Lab 1 RMD and start it up right here. And I think we go till, let me double check my schedule. I'm just going to look at times right here to make sure. Google Calendar. Awesome. We got a little bit extra time because I've got time between classes. Good stuff. Okay. Here we are. Title, Lab 1, Author, you. Make sure you have these packages installed, reg class and lubridate. You won't be knitting this, but this is just the two packages. How do you load these? Make sure to do library reg class, library lubridate. These are just options. Just want to make sure that I'm doing it right. Yeah, download the files. Download the files. If you notice, I downloaded them. Put them in your working directory. And when you go down here, you should see that we're loading up the stuff right here. We should be loading it eventually. Where are we loading it at? We'll load them eventually. Let's go down here to the first few sets of questions. When building a model, for the purposes of predictions, we often tune the form so that it is accurate as possible. One thing we can tune with the decision tree is the CP parameter used. So this is for way later on. Really good stuff. This stands for complexity parameter, which is how big the tree grows. So think about if you have a very small tree that's not too complex, but you have a very large tree, which is very complex. And this is the return we need when we're trying to reduce the sums of squares or reduce the impurity. More on this way later on, but we need to make sequences of numbers a lot of times. So this is a great kind of leading into. Use the sequence command to print to the screen a sequence that starts with 0 and goes to 1 and goes up in increments of 0.08. You'll note a quirk in the sequence if the values in the two arguments actually do the sequence, all this good stuff. So we want a sequence that starts at 0, goes to 1, and goes up by 0.08. So who knows how to write this right now? Practice. I'm going to write it out here in a second. You'll get to see the answer. Just go ahead and take a moment. See if you can get it. So when you use the sequence function, try to write in the chat. Sequence, well, one, if you don't know how to use it, boom, you can go right here and you can see the instructions. Sequence has a default order from to by. So you kind of got everything you want right here where it says from to by. Starts from this. This is basically from 0 to 1 and by right there. Does that make sense? It's now from to by. But what's even better is when you use sequence. Which one? With this right here, you can start 0, 1 by 0.08. This is the default order right here. And you can actually make it with the arguments called from 0 to 1 by 0.08. It'll give you the same thing. One thing I don't like to do, how can I make sure that I'm in my working directory? Just make sure everything is saved in your working directory. So, no worries. Just make sure you have everything saved in the directory you use. If you have issues, email me and we can double check. I might need to actually screen share, but you want to make sure you've set your working directory, which I have a video on that, using the global options right here. So make sure you have your working directory set and you put your files in your working directory for usage. When you call arguments, you can actually switch the order of them. We're really just doing the same work right here. But what is the point of this? If you notice right here, I think it should expand. Oh, that's a bummer. Here, 1, 2, 3, 1, 2, 3, 1, 2, 3. I think that did all three. Good. If you notice right here with what's on the screen, we get the same output from all three of these. Whether we do without the argument names, it still does from to by, or right here, there's a little bit of glare on my screen right there, from to by in its order that it uses, but calling the arguments, and right here, we're switching the from and the to, so it still does the same thing. But be very careful if you were to change this, which you wouldn't want to do. You should get the reverse order sequence right here, because this is a sequence from 1 to 0, and then you actually have to put the negative right here, and then that'll go in reverse order. If you don't put the negative, it gets mad at you and says it can't do that. So it's saying, no, I can't do that. So watch out. Understanding how to use this is key. Can I have more than one working directory? Only one. So if you're in both classes, I would use like a BAS folder. Good question right there, Mohammed. So we have right here, with the complexity parameter, we oftentimes want very little values. So we oftentimes use a power going from the kind of like the, right here is the, the scientific notation. You can actually just plug this into R, which is really nice. And it'll give you the number. Well, it's going to show that. We can make it so it doesn't. There, now it's showing that. I love how R does that. Really nice to get it. So by taking 10 and raising it to the sequence right here, generate the following target sequence by raising 10 to the sequence of the powers starting with this and ending with this. Now, we want to do this slowly right here. Look at this right here. It's the same sort of thing we were just doing. It's the same thing we were just doing. Who can write in the chat right now the sequence right here? So it says starting with this right here. Let me put it so we can see it. Starting with -6, going to -1 by 0.5. Should load in here. Starting with -6, going to -1 by 0.5. Starting with -6, going to -1 by 0.5. So think about just how to write this sequence, and then we'll worry about raising 10 to it. So only focus in on this first part right here. I'll double check with you, Andrew. We can hop on a Discord and I'll double check with you, make sure it's there. How are we going to write this sequence? How are we going to write this sequence? Only focus in on this. Don't write the whole thing at once. Just write the sequence right now. So we just want to write a sequence. Don't write the full thing yet. Just focus in on the first part. So how are we going to write the sequence? Just focus in on the sequence only. So only focus in on that sequence part. And then we'll just append it onto the other part. So let's get the sequence that goes from -6 to -1 by 0.5. So we want to make a sequence from -6 to -1 by 0.5. 20 points in the chart here. Who knows? Let's this thing out. Yep, right there. Great job. And then make sure to put the sequence on it. You got it. Great job, Mohammed. Excellent work. Let's throw that on right here. Yep, we'll check it out. And there we go right here. There's the sequence. Oh, was it on? There we go. I'm just going to break everything. That's the sequence we're looking for. And all we're going to do now is go 10 raised to the sequence. And guess what? It takes a while to load. We've done it. We've done it. Awesome. Great job, Andrew. Yeah, if it's needing to install packages again, it looks like you've done it. So does this make sense right here? Roderick's already had a lot of points. Love it. So with this right here, we have -6 to -1 by 0.5, and we've obtained the same sequence. The following chunk defines X to be demand of the column EX7 byte data frame of the reg class package for each part except H. Print to screen the result of running mean on the requested elements of X. All code is to be put in the chunk after the set of the question, except to use the which command for many parts. So if you notice right here, we are loading up the data frame. This will, if you watch what happens over here, it'll load up the data frame. We need to go over here to our environment, and I'll just show you again. Right here, running only this code. I have only that code highlighted, so I'm running only that code. That opens the data. It runs a data set that is currently installed into R under reg class. If it is not loading the data, you have not loaded reg class. Make sure you have library reg class running if it doesn't load the data. Now, this code right here is going to take the vector inside the data frame. Here's the vector inside the data frame. $signs connect them. And we are going to store it as the value X. So you can see here the vector. So let's go right here and do the average of all elements of X. So one thing we might find interesting right here is since we have X and we just want to take the mean of it right here. Let me double check. So run the mean on it. Yeah, it says the average. That kind of helps. So how do we just do this? This is the easy one. Let me go to insert chunks after these. How do we do this? The average of all elements of X. What's up, Wesley? Good to see you here. Thank you so much. 20 points for Wesley showing up. Thank you, Wesley. How do we take the average of all things X? How do we take the average of all things X? How do we do that? Thoughts? Bueller? How do we take the average of all thing X? Because I made the office hours, yeah. Sometimes I'll see like there'll be a drop in subs when I make all the new videos. Like subs will just like drop when I put out like all these new things here. Like, I don't want to see this guy on my... You're recommending... George right there. George, 20 points. George, great answers. Thank you, George. There we go. Is it running it? What are you doing, computer? It doesn't... This markdown file sometimes... I'm going to leave the markdown. Boop. And now we're out of markdown view. So that's markdown view right there, so you can see what it looks like when you mark down. The average of only the elements of X, which are 4,999 or greater. Okay, be careful. Let's try this. Who can tell me, so I'm clicking the add chunk button so I can look at the question while doing it. Who can tell me how to only get things in X that are greater than 4,999? So be very careful. How can I see if something is greater than 4,999? First, let's just see if something is greater than 4,999. There's 3 steps we need to do. Step 1. Find out if something in X is greater than 4,999. That's step 1. Try working on that right now. Step 2. Find the elements that meet these conditions. Step 3. Find the mean. If you jump right to the end, you don't get the practice. So someone's going to speed through this video and be like, pfft. But practice. Find out if something is greater than 4,999. So that's just little bits. Little bits. Makes it easy. Find out if something is greater than 4,999. How do we do that for the vector X? I can say every answer, but then we got to practice it. Gotta practice it. How do we find out if something's greater than 4,999 in X? How do we find that out? How can we test that? And we're gonna look at this. Great job, George, right there. You are correct. That's step 1 and 2 together. So, George, you've done it. This will tell us... Ooh, look at me making mistakes right there. That tells us if something's greater than it. These are trues and falses. And then, George, you are correct. This will give us the... Ooh, that gives us the positions. And now we want to go 2x. And let me change this right here. Well, so find the positions. And then find the elements. So here's the positions. Here's the elements. And then look at your elements right here to make sure they meet the conditions. Now, we can just simply take the mean of this. And you could just call this right here y for storage purposes. Makes it easier. And that's got it. Lots of steps right there. Lots of steps. The average of only the elements of X which are greater than 4,990. Lots of steps. Or just like when you break it apart, there's a lot to do on that screen. We first found out if something is greater than it. We found out, so this tells us, is something greater? This tells us the positions of the trues. Then we take the positions to return the elements, because this right here is just the same code right there, giving us the positions. Then we return the elements, and I stored the elements into y, and then we take the mean of those elements. Does that make sense, George? There's a lot going on right there. Little tiny question, big answer to do. So the answer is on the screen right now. But does that make sense, George? And George, thank you so much. 20 points, George. Following along right there, practicing. Does that make sense? It's a little bit tougher of a one right there. It's very short, but pretty tough. The average of only the elements, which are between 2,000 and 3,000, including those values. We basically have something really good with this code that we've already written. If you look at what we have right here, this is the inside the test right here, basically. So if you just call this the test, we could just take test right here, because that's the test we've done. So now let's just write a different test, and let's say X is greater than or equal to 2,000, and, please tell me if I'm making mistakes on this, and X is less than or equal to, and says including those values, 3,000. So now this is a logical right here, and we've already written this whole code. We can make sure that we're returning just those elements, And those are the elements that are only contained within that. We don't even need to store it. We could just do the mean of it. Look at that. All of our work previously is working together. Mubot is always here.
I am Mubot.
He's chilling out in the background. Mubot, thank you for all those points you've been handing us. You're so good, Mubot. So does this make sense right here? What I've done, I've taken my previous work and kind of changed it so that I just put test right here. Whatever test I am doing, this is just the test I'm doing, returning the positions, returning the elements in those positions. Instead of storing it into Y, I'm just now taking the mean of it. So George, please ask me to slow down if I'm going too quick or anything, but I'm taking my previous work and using it to my advantage right here by just storing something called test and then putting that test object inside of there and doing it this way. So now it's like, well, why rewrite all that when I can just be like, all I need to change is the test I'm doing, finding out the positions of the things that meet those conditions, returning those elements, taking the mean of those elements. Let me highlight as I say it. Running the test, finding the positions of the things that meet that logical test, returning back the things in those positions, taking the mean of the things in those positions. So it's a lot going on. 320 if you're watching this. This is some really good practice right here. Oh, is there A and A? What? That's weird. The average of all but the 89th element. Oh, easy one. We're finally to a really easy one. How could we remove out the 89th element of X? So go ahead and write the vector X right now in the chat. Try writing the vector X without the 89th element. Simply write the vector X minus the 89th element. Write the vector X minus the 89th element. How do we write the vector X minus the 89th element? The vector X minus the 89th element. How do we do that? So remove out the 89th element out of the vector X. That's the goal right now. Take the vector X, remove out the 89th element. This is the practice we need. Who can do that in the chat? Put a little chill music on. All this chill music. So take the vector X, remove out the 89th element. Be like, vector X, I call you. I choose you, vector X. But now I need to go to positions. Great job right there, George. Excellent work, George. 20 points in the chat, as usual. George, following along. Great job. And then we're just going to remove that element out, and we're going to take the mean of it. Boom. Done. We could view what the 89th element was. It might have been something really big. It's just that. Is that the 89th? 90th? Sure. Well, I'll be. There it is. There's the vector X minus. And that will store into X. Be careful, Cliff. Cliff, good answer right there. 20 points, Cliff. That will store into X the value of negative 89. Does that make sense, Cliff? The code currently, I'm going to just show it right here. Don't run it, though. This will store into, so that's the vector right there. This will store into X the value of negative 89. Here, watch, I'll show you. Boop. There we go. That'll store into X the value of negative 89. I'm going to rerun all chunks above, and there we go. We got that back. Double check. Good answers right there. See what the code does, and run it. The average of the 290th through 300th elements, including elements 290 through 300. So use the shortcut to make the integer sequence. What's the shortcut to make the integer sequence? Love those Mubucks. Who can write the sequence 290 to 300 shortcut of writing it? So first thing to do right here is to write the integer sequence as a shortcut. I'll probably finish off this question. Who can write the integer sequence really quickly as a shortcut right here? So write the integer sequence right now, just like that. Just be like, boom, integer sequence, done. Write 290 through 300 as an integer sequence, shortcut way of writing it, easiest way to do it. You could write it the long way. Why do it that way, though? So write the integer sequence. Great job, George, right there. Excellent work. There's the integer sequence. And now we're just going to use this as positions. You can highlight code, and then you can put the brackets around it. And we're going to go to X, and there's the elements in those positions, because we went to the positions inside of X. And the average? All B. There you go. That's how we do right there. Got it. So great job right there, Mohammed. And so that'll turn it as dot integer will make it integers. But so we would want to do as dot integer, but we won't use that here. Great answers, Mohammed. And then E, oh my gosh, what's this story? Oh, we're almost done with this. The average of all but these elements right here. Well, that's easy. We basically have it. Be careful you don't accidentally do this. So we basically have this. Because with this right here, instead of taking these elements right here, and I always make a mistake on this, we can concatenate this. And what we want to do is we want to go minus. That should do it. This has 410 elements. I hate the way that looks. Why is it going to do that? Oop. Yes, 397, 398, 399. And we did remove out 11 elements. So does this make... Oh, wait. Where's the code? There's the code right here. So I'm looking at how many elements this is returning because we're removing out 11 elements. This right here should be 11 elements long. And we're removing out these 11 elements. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that means when we run this down here, we should have 399 elements. And you can see that by 397, 398, 399. So we do have the right length. Does that make sense how I'm saying take the vector x and remove from it the sequence? But you have to be really careful. This is the mistake I think we're talking about here is where people do this. I don't even know if this is going to work properly. That's not going to be good. Yeah, you see it's super mad about that. It doesn't like that. I wonder if this will work. I'm doing things I don't think we should do. Well, wait, let me see what it did. I'm doing it in ways I wouldn't do it. I didn't close the bracket. Oh, yeah, that looks to work too. Yeah, because it's already a yeah. I don't know. I like to vectorize it. So a lot of ways of doing this right here. That looked to work, and that looks to work right there. For some reason, my R, like working directory, you're not seeing files, even though I keep restarting the working directory. Yeah, make sure to set it in the global options. Make sure to go here to global options. And then if you load files from other spots, it'll reset your working directory. So Mohammed, we might meet, or Andrew, we might meet and talk over it to make sure everything's working. And last but not least, the average of only the elements that are equal to the numbers in the sequence. Ooh, I need help, everybody. Somebody write this sequence right here. I'm going to highlight some numbers for you. What? There we go. So somebody write this sequence right here. This is a tough one. Somebody write this sequence right here. Just write the sequence. That's the only thing I want right now. Don't go too crazy. Just write your sequence. Little bits. Somebody write that sequence out for me. Write that sequence right there. How do we write the sequence? Oh my God. I think it's my nephew. I'll call him back here in a second. How do we write that sequence? How do we write that sequence? I might give it away here so I can call my nephew back. Sequence from 700 to 8710 by 10. So now we've got it. From this to this by this. And we've got the sequence right here. It looks good. We're good with the sequence. And now we want only the average of only those that are equal to numbers. So you might think equals equals. This is where people are going to make a mistake. But that doesn't do what you want it to do. That doesn't do what you want it to do. What you want it to do... Oh, Mohammed, thank you so much. We want that. This is saying, is x equal to 700? Is x equal to 710? And it goes through each element. We want things that are contained in. And now we say, is this value of x, is a certain element of x, like 985, is that contained over here? Does that make sense? Is the value 985 contained over here on the right? And now what are we going to do? The same thing we did earlier. We're going to find out the positions of these things. There's the positions. And then we're going to go to x and return the elements. Now, when I run this, I want to make sure what I see are numbers contained over here. Notice how this number 1000 would be in the sequence. The number 5170 would be in the sequence because its multiples are going up in sequences of 10. And I'm not going to show the answer right here. You have to write the answer. I don't want to show this one. I don't know if it's one of the questions. But we're just one step away. But I think that's got it. I'm going to call back my nephew here. Does that make sense? Who thinks they know what to do here next? It should be kind of obvious because we're doing that for everything. But this right here, we made a sequence going from these values to these values. We saw if X is contained in the sequence. We found out the positions of those, and then we returned back the elements that are in those positions. And we confirm it down here by seeing what these are. And then we just want to take the mean of this vector. I think that's got it. I'm going to call back my nephew. I'll be teaching here soon. Please Discord or email me if you're stuck. Please, please, please. We'll be back here later. We have afternoon office hours, so swing back by. We might even finish this in the afternoon. Swing by, say, hey, Brian, let's finish that 474. Take their mean, right? You got it, Mohammed. Excellent work. I'll talk to everybody later. Bye for now.